For lesson 65, we're going to talk about prime factorization. We're going to use two different methods. One's division by prime, one's factor trees. Okay? So every whole number greater than 1 is either a prime number or a composite number. A prime number has only two factors, one in itself, while a composite number has more than two factors. So as we look, starting in lesson 19, the numbers like 2, 3, 5, and 7 are prime numbers. 4, 6, 8, 9 are composite numbers. All composite numbers can be formed by multiplying prime numbers together. So for 4, I can multiply 2 and 2. Both the 2's are prime. 6, 2 and 3. 2 and 3 are both prime. 8, I can do 2 times 2 times 2. Okay, it's all prime numbers. Same with 9. We write a composite number as a product of its prime factors. We have written the prime factorization of the number. The prime factorizations of 4, 6, 8, and 9 are shown above. Notice that if we had written 8 as 2 times 4 instead of 2 times 2 times 2, we would not have completed the prime factorization of 8. Since number 4 is not prime, we would complete prime factorization by breaking 4 into its prime factors of 2 and 2. So, in order to have prime factorization, we have to have all prime numbers. We can't have any composite numbers. So in this lesson, like I said before, we're going to show you two methods. One is division by prime, and one's factor trees. I'm going to show you both methods to factor the number 60. So division by primes. To factor a number using division by primes, we write the number in a division box and begin dividing by the smallest prime number that is a factor. The smallest prime number is 2. Since 60 is divisible by 2, we divide 60 by 2 to get 30. Now, since 30 is also divisible by 2, we divide 30 by 2. Okay, that would give me 15. Notice how we're stacking the divisions. Now, although 15 is not divisible by 2, it is divisible by the next smallest prime number, which is 3. 15 divided by 3 is 5. 5 is a prime number, and the only prime number that divides 5 is 5, because it's a prime number. So by dividing the prime numbers, we found the prime factorization of 60. When we write prime factorization, we need to have our prime numbers in numerical order. Okay. So this is wrong here. This should be a 5. But to write my prime factorization, I'm going to look outside of my division boxes at all these prime numbers, and what I have is 2 times 2 times 3 times 5. So prime factorization of 60 is 2 times 2 times 3 times 5. Okay. So now we're going to use division by primes to find the prime factorization of 36. Okay. I better start lower. Start down here. Okay, it's even, so I know 2 is a factor. Goes in there 18 times. Okay, it's still even, so 2 again. I get 9. And now it's not 9's not divisible by 2, so I use the next prime factor, 3, it works. I get 3 on top. I know 3 is prime, so I can stop there. Okay, I have all prime numbers on the outside of my division boxes, so 36 is equal to 2 times 2 times 3 times 3. Okay? Now it says try division by prime for the number 420. Wouldn't be a bad idea to pause, try it out on your own, and then go ahead and play. I'll do it. Okay, so I know 2 goes into 420 because it's even. Okay, it goes in here 2 times here, 1 time here, 0 times. Still even, so I'm going to use 2. 2 goes in there once. 2 goes in 1, 0 times, to 10, 5 times. Okay, now 2 won't work, 3 does, because if I add up my digits, I have 1 plus 0 plus 5 is 6. So 3 is going to work, and this is why I don't like division by prime myself. I like to do factor trees, which I'll show you in a little bit, just because if we don't do this right, we can get lost. To me, I see that 5 is a factor. I would rather do 5, but for division by prime, we're supposed to go in order. Okay, so 3 goes into 10 3 times, will be 1, 15, it's 35. Okay, now I know 5 and 7 go in that. They're both prime. I'm done. So prime factorization for 420 is 2 times 2 times 3 times 5 times 7. Factor trees. To make a factor tree for 60, we simply think of any two whole numbers whose product is 60. So I'm going to write 60 up there. It's called a tree because we're going to make branches off our numbers. So I know 6 times 10 is equal to 60, so we're going to use 6 and 10 as the first two branches of the factor tree. The numbers 6 and 10 are not prime numbers, so we continue the process by factoring 6 into 2 times 3 and 10 into 2 times 5. Okay. Now, if one of our numbers off our branches is prime, I'm going to circle it to say that's the end of it. Now, notice all these are circled, they're all prime. The circle numbers at the ends of the branches are all prime numbers. We have completed the factor tree, so we'll arrange the factors in order from least to greatest and write the prime factorization of 60. So you have 2 times 2 times 3 times 5 is the prime factorization of 60. Okay? This is my favorite method. I think this is easier because you can break it up into multiplication facts that you know. So here I'm going to use a factor tree to find the prime factorization of 60 using 4 and 15 as the first branches. So here I use 6 and 10. Now I'm going to use 4 and 15. Because 4 times 15 is 60. So what times what is 4? Well, 2 and 2. Those are both prime. I'll circle them. For 15, I get 3 and 5. Those are both prime. I circle them. Now, all my numbers are circled at the bottom of my branches, so I can write my prime factorization in numerical order. I get the same thing. 2 times 2 times 3 times 5. Okay. Go ahead, do the practice set. If it tells you to do a factor tree, do a factor tree. If it tells you to use division by primes, do division by primes. Okay. After we do a practice set, even if it asks you to do a certain way, I'm probably not going to care which way you do it because you should get the same answer. I'd rather have you do it the way that you like best. So go ahead, do the practice set. Make sure you do it how they want you to do it so you get practice in both ways. If you have any questions, make sure you bring them to class.